Okay, good morning everyone. I think we should start. Thank you very much for coming to today's symposium on behavioral genetic studies of personality, cognition and behavior. We've got 5 talks today, and these 5 talks will be presenting novel insights from quantitative genetic and molecular genetic studies of individual differences. And the first speaker will be Juliana Gottschling from Saarland University, and she will be talking about the prediction of school achievement from intelligence and from motivational factors using a quantitative genetic design. The second talk will be by myself, and I'll be talking about longitudinal associations between ADHD symptoms and reading. Nora Walter is our third speaker. She's from the University of Bonn, and she will be presenting a molecular genetic study of alexithymia. Sebastian Marquette is also from the University of Bonn. He will be talking about individual differences in executive control. And our final speaker is Julia Kovács from Goldsmith University, who will be talking about individual differences in number sense. And I suggest we start with our first speaker, Juliana Gottschling.
So, good morning to everyone, and as Karina said, I will talk about the prediction of school achievement from a behavior genetic perspective, and I will present some results from the German twin study on cognitive ability, self-reported motivation, and school achievement, in short, COSMOS. And specifically, I will focus on the prediction of school achievement by cognitive abilities and self-perceived abilities, and I'm going to compare our results with some results from the twins early development study TEDS. So before talking about the results, I will give just a brief overview about the theoretical background and the COSMOS study itself, as well as the measures we used. So referring to phenotypic studies, it can clearly be said that intelligence is the single most important predictor of academic achievement, and it explains around 25% of the variance in academic performance. But this leaves a lot of variance unexplained, and one good candidate to add additional variance is self-perceived ability, and the positive relation between self-perceived abilities and school achievement is theoretically well-founded and empirically affirmed. However, given the substantial overlap between cognitive abilities and school achievement on the one hand, as well as self-perceived abilities and cognitive abilities, it's worthwhile to make sure that all associations between self-perceived abilities and school achievement are not confounded by IQ. And that is exactly what, for example, Spinat and colleagues found in their 2006 study. Self-perceived ability independently predict school achievement. So looking at the causes of individual differences in these variables, we can clearly say that cognitive abilities and school achievement is substantially heritable. And but when we look at self-perceived abilities, there are only few studies available so far, but they yielded a substantial amount of genetic effects at around 50%. And when we look at multivariate genetic studies, we can say that genetic effects are the primary source of variance underlying the covariation between intelligence and school achievement. And finally, self-perceived abilities predict school achievement mainly as a result of genetic effects. So what is COSMOS? COSMOS was initiated by Frank Spinat in 2005, and it aims to investigate predictors and influences of school performance in a genetically sensitive design. and we started with elementary school children. And on the one hand, Cosmos tries to mirror TEDS in that it was inspired to replicate some results from the TED study, and that is exactly what I will talk about today. And on the other hand, Cosmos brings in new information to further explain the etiologies of diverse influences on school achievement. So we extended the set of measures with further motivational constructs, specific environmental variables, individual and familiar characteristics, and so on. So Cosmos is a longitudinally designed study, and we have had 3 measurement occasions so far, with a two-year period between each measure. And as you can see, from over 1,000 families, we have originally contacted almost 300 pairs of children participated in at least 2 surveys. And the data I will present today only refer to a cross-sectional point of view at the 3rd measurement in 2009, where children were 13 years of age and they participated at least 2 surveys. By the way, the compared results from TEDS are based on a cross-sectional sample of 9-year-old twins. So for today, for the analysis, I will present today only 3 constructs out of relevance. First of all, cognitive ability, which was operationalized by 2 verbal and 2 non-verbal tests. And for the relevant 3rd measure, we tested the children by phone with trained interviewers, and we yielded a strong G factor. The second one is self-perceived ability, and to measure self-perceived ability, we focused on the highly elaborate expectancy value model from Jackie Eccles and colleagues, which has proved its appropriateness, especially in the school context. So according to the model, self-perceived abilities are defined as the children's belief about how well they will accomplish an upcoming task. And if you are familiar with the Eccles model, you know how SPAs are typically assessed. So we ask the children, how good do you think you are at doing a specific task? For example, doing reading or writing or solving number problems. As criterion, we used school grades from 2 semesters for each school year, and it should be mentioned here that the achievement criteria was something different in the TED study, so they used a teacher rating based on the national curriculum score. And for SPA and achievement, we got information from different school subjects, for example, math and German. But I will only be talking about the results related to the school subject math today. So let's come to the first results. And what you can see here are the phenotypic correlations between our latent factors. And as expected, we found moderate correlations for IQ, SPA, and achievement in math for the students at the age of 13, and we found moderate to high factor loadings for the specific measures of the latent factors, which suggests that the latent factors captured the variance that was common among these measures. And I will now turn directly on to the genetic results. And what we did are common pathway models. And you can see here the estimates for A, C, and E. And overall, the results are comparable with the TEDS data for the 9-year-old children, in that we found genetic effects for all 3 variables. Additionally, found for IQ and achievement moderate influences of shared as well as non-shared environment, but a reverse pattern shown for SPA. Here we found minor influences of C and moderate influences of E. But the key question we wanted to answer was what the rules of nature and nurture in the association between SPA and achievement independent of IQ are. And therefore we used Gottschling decomposition as a multivariate genetic approach which investigates in the origins of the covariance between traits. So with this method, the genetic influences on IQ, SPA, and achievement are decomposed into variants that could be attributed to first a genetic factor that accounts for variance in IQ, SPA, and achievement. Second, a genetic factor that accounts for variance in SPA and achievement, but that is independent of IQ. And finally, a genetic influence that is specific for achievement. So what we got for the Gottschling decomposition is what you can see here on this slide for the genetic path, and we found that same genetic factors that explain 31% of the variance in IQ also account for 20% of the variance in achievement. And second, that genetic factors associated with self-perceived abilities account for 27% of the variance in achievement. Although this path is non-significant due to our smaller sample size than TEDS, but the coefficient is as high as in TEDS. And finally, we found no specific genetic effects for achievement, and that is a first difference between the two samples. And another difference we can observe, we observed for the shared environmental path, which you can see here on this slide. So we found that shared environmental factors associated with SPA account for 29% of the variance in achievement. And in TEDS, the C effects were largely measure specific. So that's another difference between Cosmos and TEDS. And by the way, this path is also non-significant. So finally, for the non-shared environmental path, we found that they are largely measure-specific, and that was also found in TEDS. So to conclude these results, first of all, SPA is influenced by genetic factors and non-shared environmental factors, a result which was found in both independent twin samples, and this stands in contrast to the prediction of theories in educational psychology. So the finding suggests that that it's much more child-specific instead of a family-specific etiology of self-perceived abilities. Second, this was the first difference between TEDS and Cosmos. We found no specific genetic effects for school grades. So all genetic effects in school grades can be explained by genetic effects shared with IQ and SPA. And in TEDS, they found substantial specific genetic effects for the teacher rating. So there's a difference between the teacher ratings on the one hand and the school grades on the other. And finally, the association between SPA and achievement is to the same extent due to genetic and to shared environmental influences in the Cosmos data. And that is an interesting difference, although our path didn't reach significance. So the question is could this be explained? And I have some obvious explanations. First of all, the age was different in the two compared samples. So in TEDS, the children were 9 years of age, and in Cosmos they were 13. And the second explanation could be that we had different operationalizations of SPA in school achievement. So in TEDS they used a global measure of self-perceived abilities, and they combine self-perceived ability of math, English, and science to one global measure, whereas we used domain-specific measurement for the school subject math, because we think that this is more in line with self-concept theories. So the other one is that in TEDS it's a national curriculum teacher rating, and we used grades for the 2 semesters, and it could be a difference, could make a difference. And a final idea comes from a more conceptual level, in that our Cosmos sample is somehow selective with regard to the school type. So more than 60% of our children attend grammar school, which could provide a very homogeneous learning environment, which could reside perhaps in a C effect for the covariance between the two latent factors. And and this fact can also be explained, for example, with the big fish little pond effect, or that self-perceived abilities and grades are established within the class context. So the other children, the children compare themselves with the other children in the class, and the teacher gives the grade in relation to the children of the class. So I think I was very good in time. So thanks for your attention, and please feel free to ask some questions.